Hello, good morning viewers. In our previous lesson, we have evaluated the cube root of unity applying the Mover's theorem. So into this tutorial, we are going to take an algebraic approach by letting the whole of this to be equal to a certain variable. So let's get started. I would like to let the whole of this to be equal to x. Our main goal is to get that complex number. Otherwise, we can just evaluate this to be equal to 1, right? So let x equal to this cube root of 1. If you take the power of 3 to both sides, you're going to eliminate the cube root to the right hand side. So to the left hand side, we have x to the power of 3. Then to the right hand side, we have 1. So let's bring everything to one side. We have x to the power of 3 minus 1 equal to 0. But remember, 1 can also be expressed as 1 to the power of 3. Hence, we have difference of two cubes. So this is x to the power of 3 minus 1 to the power of 3 equal to 0. Remember, difference of two cubes, if you have like a to the power of 3 minus b to the power of 3, this is the same thing as a minus b, then multiplied by a squared plus b squared, then plus ab. So let us apply the same principle here. This can now be factorized as, let me rewrite it, x to the power of 3 minus 1 to the power of 3. This is equal to x minus 1, for which x is equal to a and 1 equal to b, then multiplied by x squared, then plus b squared, which is 1 squared, but let me take it to the end. A times b, meaning x times 1, that is x. Then b squared is the same thing as 1 squared, that is 1. The whole of this equal to 0. So since we have two factors multiplying each other and the result is 0, it implies that either the first one, x minus 1 equal to 0, or the second one, x squared plus x plus 1 equal to 0. From this factor, you can see clearly that x must be equal to 1 for this statement to be true. So x equal to 1. This is one of our solutions. And the second one, we have to apply formula because we cannot factorize it. So you can see the leading coefficient, which is a, is 1. That is b equal to 1, and c, the constant, also equal to 1. So x from the formula will be equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. So now let us substitute. X is now equal to minus b, that is minus 1, plus or minus the square root of b squared, which is 1 squared, minus 4ac divided by 2 times 1. X equal to minus 1 plus or minus the square root of 1 squared is 1, 4 times 1 times 1 is also 4, divided by 2 times 1 is 2. We're still looking for the value of x. So this is equal to minus 1 plus or minus the square root of negative 3 divided by 2. Square root of negative 3 is just square root of 3i because we are in the complex world. So this is finally negative 1 plus or minus root of 3i divided by 2. This is another value of x, but if you like, you can split them. We have the first one as x equal to negative 1 divided by 2 plus root 3 divided by 2i. Or the second one, we have negative 1 divided by 2 minus root 3 divided by 2i. Remember, the first value of x was x equal to 1. And hence, these are the three solutions to this problem. Square root of unity could either be equal to 1, negative 1 divided by 2 plus root 3 divided by 2i, or its conjugate. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.